Good afternoon, good morning, and good evening from Norfolk, Virginia. My name is Rafael Andaeta. I'm the Associate Dean of the College of Engineering at Old Dominion University. And today I have the honor to introduce you our next speaker, NASA engineer, Dr. Jose Nunez. Dr. Jose Nunez is the manager of the University Partnerships and Small Satellites capabilities at the Kennedy Space Center. In his capacity, he is tasked with increasing collaborations between university principal investigators and the Kennedy Space Center, as well as leveraging infrastructure to increase university small satellites development activities. Before that, he was the chief of the Flight Technologies branch for the Exploration, Research, and Technology Programs Office at the Kennedy Space Center. That being said, I let you with Dr. Jose Nunez.
Thank you, Dr. Landayeta. It's a pleasure for me to provide this. Hopefully you're looking at the agenda, so I'm going to be kind of a little bit fast because there's a lot of charts to talk about. So I'll be talking about the plan going back to the moon called Artemis. So you know about Apollo. Well, from Greek mythology, we find that Apollo had a sister. So from now on, anytime that we're going to the moon, you'll hear the name Artemis. That's the name of the program. We'll talk about who we are, KSC SwampWorks, and I'll talk about that. Talk about our research technology portfolio, the areas that we focus on, the research and technology areas that we support, some of the INSPIRES and research opportunities that we have at KSC, and perhaps for this group, the most interesting would be the undergraduate, graduate, and postgraduate fellowships. So perhaps talk a little bit faster through these areas, but then these charts will be available. Dr. Landayeta will have them, so he will be able to share with all of you, okay? So from an integrated schedule, we're gonna be flying Artemis 1, which is our first test flight towards the end of the year, followed by Artemis 2, the first crewed test flight in 2022, and then followed by Artemis 3, which is where we're actually going to have boots on the moon. And by the way, this is the first time that a female astronaut will be landing on the moon, followed by the next American man. Okay, so that is our schedule, and it goes right. More details, but for now, this is the key takeaway. In terms of our operations, first Artemis. Second is going to orbit astronauts to the moon, and then the last one's going to actually go to the surface. And this is just a overview, the scale landers that we're planning on having, the actual capability that we'll have in place. We will also have this thing, Gateway. You could think about it as a small space station that's going to be orbiting the moon in what we call the linear helio orbit that will approach the south pole of the moon very closely, so the astronauts could actually then go to the surface of the moon. Trajectory for the second flight, so we'll be launching from Cape Canaveral, going out, doing our first perigee maneuver to get us out of the orbit, followed by the second one, and then we're actually just going to go around one more time, then go all the way across the moon, get close to the moon, about 4,000 nautical miles, and then come back and land pretty much as Apollo did in the water. Okay. Here's also, so Gateway is going to be the moon. So any launches that we have, any type of transit will be docking to the Gateway, and then from the Gateway we'll be going to the surface of the moon and then coming back to it before we get back home. So the time is now. We have the capability, we have the purpose, we have the charge, and we have the responsibility. So we're trying to make or recreate history again. In terms of centers, right? So I'm from the Kennedy Space Center. So this is where I am. We have 10 NASA centers, as you probably know, the United States. And other NASA facilities are in purple, and then green are some are federally funded research and development centers. But basically, I'll be talking to you from a Kennedy Space Center perspective. All right, so who we are and what we do. So I am now in the research house. call that Swamp Works. It's kind of like an offshoot of Kelly Johnson's Skunk Works mentality, where we kind of like lean forward, fail fast, fail forward, learn from our mistakes, and do that again. So this is a little picture of our high bay. Another one, we have capability for machine shops, technology incubator area, innovation space. We also have 5 labs, or 6 areas of focus. We have our granular mechanics and regolith operations. We have our applied chemistry. We have an electrostatics and surface physics laboratory. This is the one that I used to be the head of. Advanced materials and systems, applied physics laboratory, and corrosion technology. So they're pretty much same type of labs that you would find in any university, but our focus is basically to going into space, to developing the technologies to go back to the moon and to Mars. So it's the focus, which is a little bit different. In the next couple of charts, I basically go through our primary center roles in terms of research and technology. Perhaps not too much interesting for students, but it's a way that I use to communicate to university principal investigators and any other commercial entities what areas we, Kennedy, are interested in or are working in, and for collaboration. So letters A through this page, these are all the areas that we basically work in or do research in, as well as from M to W. So for those who are interested, PIs that may be interested, they could get a hold of me afterwards. And if they have any questions about food production, water nutrient recovery, or even in-situ resource utilization, you could always talk to me and we could just go down a little bit further. So those are basically the 2 primary charts that talks about our Kennedy research and technology portfolio. In addition, we support other programs within the NASA agency, right? So we support the Space Station program. We support something called Space Technology Mission Directorate, or STMD. We support Space Life and Physical Science Research called SLIPSRA, Human Research Program called HRP, and the Advanced Exploration System. So all of these programs, I'll talk just a little briefly about, and how is it that we support them. So for the ISS, so this is ISS. I worked with the ISS for 21 years. If you haven't seen the ISS fly around, I would propose you definitely do. Spot the state.nasa.gov is a site that you could use. And just in case if you were wondering how big the ISS is, it's half size of the Enterprise. Just saying, if you're a Star Trekkie fan, you'll now get it. So this is our facility that we use for processing all the elements that go into the ISS. Basically, let me show you a picture better than words. So the ISS is complete, but there's a lot of spare parts that require. So anytime that they need oxygen or nitrogen, we supply them with these composite overpressurized vessels that we process up to 6,000 PSI. So we do that at the Kennedy Space Center. Also, anytime that they need to update or replace a battery, lithium ion battery, typical to what you have in your cell phone, we supply those as well. So Kennedy is actually like the warehouse. Indiana Jones movie that had a picture of a warehouse filled with boxes. So we have one of those that houses all the spare parts for the ISS. So this is the high bay that the space station facility has. This is where I spend most of my time working in elements of the ISS. Here we have an example picture of the orbital ATK, which now is called Northrop Grumman, of their module being processed at in the clean room. Okay, this is just another view of that being integrated into their propulsion module. So this is the area that we have that we process flight hardware in. So now on to the Space Technology Mission Directorate. So here is a program that's got a lot of different groups of technology development. Some of it is low technology readiness, the other one's middle, and the other one's a high. So these type of programs individual university PIs could actually apply for funds so they could continue doing their research. And this is in terms of you use these for low technology, you use these for middle, and you use those for high. So in-situ resource utilization is something that we're spending a lot of time focusing on. We have a big dust bin in our Swamp Works high bay, in which we actually develop either robotics to help excavate the regolith, which is just a fancy name for dirt, or developing tools to excavate. So that's something that we do as well. So this is just another picture that we're trying to utilize. Rather than bring things to the moon or Mars, we're trying to figure out what tools we can use so then we could actually utilize the resources that are there, convert them to something useful. Just like the early explorers went from east to west, right? The pioneers, they didn't bring everything with them, but they brought tools, fishing poles, saws, so they could cut trees or fish for food. And then basically, primary resource that we could get from regolith is oxygen, CO2 from the atmosphere of Mars, which is, very high content. We could get metals. So imagine getting metals from regolith and using it as a 3D feedstock for your 3D printer. So that's some of the things that we're working on. On the SLIPSRA side of the house, the Space, Life, and Physical Sciences, it's got a lot of words. So it's mostly about food. So if you ever see someone, an astronaut, eating a leafy lettuce from the space station, that whole experiment, the seed that developed into this lettuce, the lighting, everything came from the Kennedy Space Center. We are the lead for the whole agency on food production. So we're basically trying to get from packaged food, which is what the ISS actually, the majority of the food is done by packaged food, dried food. We're trying to go into more of a fresh food environment, growing, vegetables and leafy greens. And for the future of the gateway or even a surface in Mars, we're trying to figure out how we evolve from the experiments that we have on the ISS to something that could be more autonomous in the surface of the moon or even in the gateway space station. Onto the Human Research Program, HRP. Here we basically focus on research operations and the integration. They have 5 key elements, but we only support them on that one. And it's just what we do is we basically look at the microbiome of that which is being grown on the ISS and compare that to, supermarket, Publix, whatever market, Whole Foods type of microbiome that is in their vegetables. And we compare them. Are the astronauts eating more microbes than that which you could buy at Publix or not? So that's something that we're also doing. And lastly, the Advanced Exploration System. This is more of an internal NASA research where we have different projects going on, monitoring radar for near-Earth orbiting characterization, CubeSat launch initiatives is a little bit separate, so on. And then on small satellite capabilities, like Dr. Landieta mentioned when he introduced me, we're trying to leverage our expertise to help universities develop theirs as well. So I've been going across the state of Florida trying to help those universities that need little help on developing their satellites with expertise. And we have a lot of capability that we could also leverage from. So that's things that we do. So now, how do we get you involved? This is more of a, how does it impact you? So those are our principal investigators. We have something called NSPIRES, is a portal for research. So any research opportunities that we have are posted or is posted in this system called NSPIRES. And anyone can register, even you as a student, if you want to do that. You could just get emails, emails about all the opportunities that are coming out. One of the largest ones is called ROSES, or Research Opportunity in Space and Earth Science. And that one has a lot of addendums that come out throughout the year. The big one comes out typically in Valentine's Day and is for opportunities for basic and applied research, technology development, guest investigator programs, and early career. And I'll show you a little glimpse of what that means, okay? Also, I tell investigators that to be a successful PI in terms of winning grants and such is that perhaps you would like to gain some insights by becoming a reviewer, a panel reviewer. And that helps to kind of understand, you know, what is NASA really looking for. So just a food for thought for the PIs. And that's where, this is just a screenshot on how you subscribe to their mailing list, how to volunteer to the review panels. Now this is just a screenshot that I took earlier today from the NSPIRES website. These are the proposals or notice of intents that are due in the next 30. It's got 3 pages. So for instance, this one is for, you know, if you want, or if you're interested about Earth Science U.S. participating investigator, you would click there. If you want to do some Cassini data analysis, you can click there and it tells you the due dates and so on. Or if you want to develop an advance of lunar instrument program, you click there and so on. So it's just, this is another page. University Leadership Initiative, if you're interested in something like that, you would do that. And so on. So it's just where we post our research for university or research institutions to propose to guests. Okay. Hopefully that's for a principal investigator. This is, I know all about NSPIRES, which is good. If you're a principal investigator and you don't know about NSPIRES, then please take your time to look at it. Is that NASA Solve. This is a kind of like a one-stop website where you find opportunities to participate in challenges, prize competitions, and science activities. This is really good. Please, you know, you could just Google NASA Solve and it'll get you into this website, and you could click on all of these different type of challenges, and you could propose to submit an application, talking to a mentor and the faculty and such. Some of these awards are like 150,000. So it's not little money, it's medium money. So you may want to think about that. So NASA Solve. And then I've just got, I'm going to skip some of these. These are just some of the research opportunities that we have. Like Kennedy has this technology advancing partnerships called TAP. You would click there. It's going to be in the fall. It's not much amount, it's about 30K, so it's not typically that much money. But if it's a way to kind of get into the KSC side of the house and understand what it is that we're doing. So that's one called Technology Advance. We have the Small Business Innovative Research or the Small Business Technology Transfer. And I put this here because a lot of the faculty have side businesses and so on. So it has 24 topics. The three out of those 24 topics are the ones that we're really interested in, namely focus area 8, 16, and 24, which is In-Situ, resource utilization, grant and launch processing, and dust mitigation. So that's what that is. We also have some small technology partnership solicitations. This one, it's got the new one has not popped up, but it actually provides funding for university to develop a small spacecraft. Okay. Another small science studies, another solicitation. This one just passed, but then again, you could just look at the for other ones. And this is our CubeSat launch initiative. So if you were to have a CubeSat already ready, this will actually provide you with the ride. I'm going to skip phase 1. So here, undergraduate and graduate research opportunities. So as a student, if you would like to become an intern, that's the website to look into. The deadline for the fall is July 6th. To become a employee, as you're still in school, you would apply there. It's called the Pathways Program. So it's a path to get into the NASA system. Or if you already have graduated and you already have your degree and you're just looking for a job, it's usajobs.gov, and that is for any federal job. Okay, just wanted to mention that. So in addition, we have a lot of other undergraduate programs, like this one is a summer undergraduate program for planetary research. This is an 8-week summer internship. You could find out everything about it there. The next deadline is January 21st, but that's pretty cool, right? 8 weeks. Other opportunities is the NASA Student Airborne Research Program, and also an 8-week summer program for rising seniors to acquire hands-on experience on an Earth observing aircraft. So if that's something you're interested in. Feature investigators in NASA Earth Science. That's another opportunity. Click there. Some of these I have the last time they were open, but if at least you have the website, you could just always go back and check. For Florida universities, I work with the Florida Space Grant to have them do or help us with senior. So that's something that perhaps you guys could look into as well. Basically provide them a couple of topics and then have universities work on those. NASA Fellowship Activity. This is for university graduates to get either their master's or PhD. So that's a really good one. This just closed and back in February, but it will be open again in 2021. So it's something if you want to pursue your education for a master's and PhD, this would be one to look into. And then we got postdoc programs. MPP actually happened to be the NASA postdoctoral program point of contact at Kennedy. And there's 3 different types of applications or 3 different time frames. NASA Develop, it's another training program you could look into. The Hubble Fellowship Program, so if you're into astrophysics, this would be the one for you. We have other, lot of opportunities, fellowship in astrophysics, the new investigator program and heliophysics early career investigator program, the NASA Space Technology Graduate. Again, many different things. Once you get the charts, you'll get the information. And then this one is a principal investigator role. So from a faculty PI perspective, if it's something that you're interested in, we actually have been having workshops on how to become a mission principal investigator, which is not an easy thing to do, because you're not just responsible for an instrument, you're responsible for the whole mission. So that is, well, there you go. Perhaps a little fast, but I'm just trying to show you, and I could have spent a little bit more time on anything, on any other chart, and if so, perhaps if you have any questions, we could start taking them now.
Yeah, Jose, we have probably 10, 15 minutes for questions, and there are many questions with respect to careers. So I'm going to start with the first one. This is from Ana Patricia Islas from Mexico City. How can a non-US citizen apply for an internship or work a job at NASA? How can we apply as in the astronaut program and not being US citizen, if that's possible? And how will it work for Mexico? Can you provide some information about internships that you were talking about? And I think that you were clear on the internship, but can you answer the previous questions?
Right. So can I go here? So it is a little bit of a hard answer. You know, NASA is a government agency. They hire US citizens. There's no ifs, buts about it. In terms of non-citizens getting NASA, it's basically not possible. Contractors that support NASA hire non-US citizens, but that would be on their account. I would then guide you though from a fellowship perspective, the postdoctoral program does not require you to be a US citizen. But this requires you that you are either have your PhD ready or finishing. So this program is open. It's an international program. In fact, we have a lady from France who's doing her postdoc here at Kennedy Space Center. So that's open for any internationals. But when it comes to a job with a with a U.S. federal agency, the requirement is that you have to be a U.S. citizen.
Okay. Another question, if a U.S. citizen, this is from Jesus Ricardo Rodriguez from Culiacan, Mexico. So he is a U.S. citizen, but he lives in Mexico. Can he work from Mexico?
Yeah, I mean, if the key, the golden ticket is to being the U.S. citizen. If he applies for, let's say, and he gets picked, it would be perfect because, you know, this summer we're only doing virtual internships. So he could have gone and said, yeah, if you're interested in doing a virtual internship, then yes. So we don't, you know, this teleworking doesn't really matter where you're at, but to be able to apply for the internship, you have to be a U.S. citizen.
Okay, this is more specific. So if I want to get a job researching machine learning, can I do this with a bachelor in physics and data science, or do I need to have graduate school?
So okay, so machine learning, it depends in terms of, so at Kennedy, we don't do much of, I mean, if you're talking machine learning like in robots, then yes. And just with a physics degree, a bachelor's, if we are looking for physicists, then we would hire a physicist and to work on that area. If you have, let me just go back to this. So if the individual already has their physics degree or is about to, please go into usajobs.gov, and you could search by Kennedy Space Center, which is the center that I'm in, and see if there's any physics openings. We have, and we will have many more openings here in the future. So just be looking into those. Now, one thing in terms of getting in, but you have to realize that when we put in advertisements for people, it's because will we have a specific need for someone who's doing research or machine learning? Maybe, maybe not. Perhaps the best way to continue in that path is to, yes, do a graduate level degree to continue doing.
Yeah, that question came from Juliet Gontek from Philadelphia, Pennsylvania. So next question is related, comes from Stephanie, actually from the University of Central Florida, your alma mater, my alma mater. And she asked, what kind of opportunity, if any, would you recommend for those that graduate with a computational physics Bachelor of Science without having an interest in engineering? Will obtaining a master's or a PhD be preferable to actually work in the Kennedy Space Center's SWAM work?
Well, as a computational computer physicist, wow. So I'll refer you back to usajobs.gov. If you already have it, I tell folks, try to get in first. I mean, whether you have a master's or physics. I mean, if we are looking for physicists, we are looking not just for physicists that come out of school, but physicists that have experience. If you want to continue your education, there's nothing wrong with that. We do hire folks with masters. In fact, that's, yeah. But I would also, if you're really interested in working at the Kennedy Center, then, you know, put effort into trying to get a job with the Kennedy Space Center. And then once you're in, we do have programs to help you, you know, get a higher degree. It's a competitive program, but nevertheless, it's there. So, so that's what I would say. Go Knights.
Cool. Morgan Coltrane from Mollisey, Virginia asks, I'm unsure if this question will be in your field, but do you think someone could work for NASA in a more science-based field of engineering, such as biomedical, or are they more focused on the physical science?
Yeah. So we have we have about 2 to 3 medical doctors that work for NASA, and they're more of the, making sure everybody's safe and so on. Biomedically per se is not a technology area that we are working at Kennedy. So that's a field that we are just not in. However, in terms of medical doctors, we do have, and they do hire them because we have them, but they do more of the human physiology, making sure that everybody's safe. This now COVID stuff, they're heavy into making sure everybody's safe with the whole masks and thing, but not from a research perspective, if that helps.
Okay. Marcelo Fernando Condori from La Paz, Bolivia asks, good morning, Professor. I want to express this presentation is quite interesting. I have one question. Do you know about opportunities for remote free workshops or webinars regarding space technology applications?
That's a good one. So, yeah, okay. So for small sat, so a lot of conferences are now being held free. So the small satellite conference that is usually held in Lorton, Utah, something like that, it's free. So if you want to participate in a conference about technology on small satellites, that would be my go-to one. That happens to be free this year because of all this craziness that we're going through. And then I would also just Google space technology mission directorate, and see whether anything pops up. So we're seeing that a lot of conferences that would have been held in person are now being held. So I would say to the individual to Google it.
Okay, this is a more broad question. What Diego Donovan from Livermore, California asks, what are the reasons that NASA wants to return to the moon with the Artemis program?
Oh, that's a great question. So that's the thing, because we could go down the argument of, spend the NASA funds and helping some other things, but you and me, the human in us, we are explorers. We're meant to, explore and develop and figure things out. So we're we're planning on going back to the moon, and this time to stay is so to figure out how is it that we could live in a different planet. The south pole of the moon has already been proven to contain water ice, right? A couple of satellites have proven this already, L-Cross and something else, I forget. With water and ice, we could actually take that water and, H2O, we could break it down into hydrogen and oxygen, which is what? Fuel for a rocket. So we could actually don't have to carry fuel, and we could use that and then go further out. And because it's so close to us, right? It's about 250,000 miles away, which is a lot less than Mars, right? Mars is with the current technology, is a 6-month trip. The moon is only about 3 days. So why not use the moon as that test bed to really prove all the technology that we're trying to develop? And if we get into trouble, hey, it's just a 3-day back trip to home, right? Because if you test technology in Mars, well, that's a long haul to get help. So that's why we're going to the South Pole specifically.
So this is another interesting question. It comes from Nakul Shinnakumar from Chennai, India. And he asks, how far into space do you think we will send humans by the end of the century?
Oh, well, our plans to go to Mars would be is in the 2030s, which That's our current plan. But it's all driven by technology too, right? I mean, who's to figure out that somebody comes up with a engine, right? You know, hit something and engage. Uh, this current technology that we have, which is the only thing that we have, you know, it's solid or liquid propulsion, which is no different than what we use for the Apollo, you know, flights when we went to the moon. Even the that we're flying, that SpaceX or ULA is flying, they're based on liquid or solid propulsion. So in terms of propulsion, and there hasn't been that much breakthrough. But if we ever were to develop, you know, different type of propulsion, then yeah, I think anything is for grabs. But it's all technology driven.
Okay. Here's another interesting question. Evelyn Paola Gonzalez from Monterrey, Mexico, is asking, how often does the ISS need to need oxygen supply from Earth?
Oh, that's a really good question. So it's a function of how many people are there, and it's a function of how many times we get to go outside through the airlock. So like any diver, you know, when you go into diving, you need to get, when you go deep diving, you got to make sure that all your, you know, nitrogen in your blood is out. Well, the same thing with the astronauts. They spend a lot of time in the airlock breathing pure oxygen before they're able then to go outside, you know, out onto the outside of the ISS. So that uses oxygen and nitrogen because we got to replenish it once they come back. So we have every 3 months or so, we're launching resupply missions to the ISS. Lately, it has been, you know, the Russian side, right, through the Soyuz that they've been sending supplies and astronauts. Now, with the proven capability that we've been sending supplies through SpaceX and through Northrop Grumman, and now SpaceX just supplied crew. So we'll be able to supply whatever they need uh, when they need it. So, you know, depending on the schedule. But and the ISS airlock has 4 huge tanks on the outside. So we replenish those tanks. So those little black tanks that I send in, they're like a resupply. We basically attach them to from the inside, and they basically fill out the outside tank. So every 3 months, we kind of supply them with either oxygen or nitrogen, depending on what commodity that they need. Good question.
Ana Patricia from Mexico City is asking, is NASA and the Kennedy Space Center developing the Artemis program in conjunction with the private space industry as a SpaceX, or do you have separation plans?
So, so Artemis is the NASA program, but don't forget that through it, we're contracting with a lot of commercial companies to develop the capability to do that. So commercial landers. So NASA has put out a solicitation in which industry responded for commercial landers. So we're buying, in many cases, we're actually buying those services rather than NASA being the designer, developer of such. So it's kind of like a partnership more so, in which, you know, like NASA is definitely designing and building the actual, you know, SLS rocket, but we got supporting us as well. So it's a combination of NASA and contractual work.
Okay, a question in the same line of Artemis from Arthur Mazzio from Fairhaven, New Jersey. How long will astronauts on the Artemis 2024 mission be on the surface of the moon, and what do they intend to bring back, if anything? Also, does NASA have any room for nuclear engineers?
Excellent. 2 questions. So the plan currently for the 2024 mission is to have the soiree or the party last about 6 to 7 days on the surface of the moon. There will be So remember that we're going back to the moon in 2024, but not just to one or two, but we're trying to establish the infrastructure to continue to do that. So we're going to be going back to the moon, but it's going to be a long haul. We'll have a little infrastructure capability on the moon. From it, we'll then be able to be going further out. So we're going to the moon to stay, not just to, pick up samples and such. But in addition, we will be picking additional samples, just like we did in the Apollo missions, and bring them back to us, back to Earth for analysis. In terms of whether NASA requires nuclear engineers, I will tell you that a Kennedy is not something that we specifically look for because it's not within our research and technology area. We are not developing any nuclear type expertise, but perhaps some of the other centers would. So I would suggest for you to, if you have your nuclear engineering degree already, to just look into usajobs.gov for across any NASA center, because there may be a need. I'm 99% that we don't specifically look for nuclear engineers because we just basically don't have anything. I mean, when a nuclear mission comes through to be launched, we host them, but we don't do anything nuclear engineering related, if that makes any sense.
Here's a quick question, but I want you to answer. Sheila Patricia Ramirez from Puerto Rico is asking, can Puerto Ricans work in NASA?
One of my good friends, Kelvin Ruiz, is Puerto Rican. Puerto Ricans are U.S. citizens. So U.S. citizens are, yes, allowed to apply and get. In fact, I went to Puerto Rico last year on an interviewing trip. I went to the one in Bayamón, University, forget it now, the one in Bayamón. It was a big thing that we had there. We were there like about a week, interviewing kids, giving them ideas and what it is that we do. So yeah. Oh.
Okay. Here's another a good question from Akhilesh Malgun from Harrisburg, Pennsylvania. He is asking, what discoveries or inventions are you looking forward to most in the field of space exploration in the next few decades or so?
Well, from our, so I'll do it two ways. From a human perspective, we're not there yet. And that's something that needs to be fixed. And what do I mean by that? So radiation creates havoc to the human person, right? And the lack of the 1G radiant, the lack of gravity, does the same. I mean, we are meant to be in 14.7 psi per, we need it. Astronauts today have to spend 2 hours every single day exercising, creating resistance such that their muscles don't atrophy. In addition, the bone, if you don't do exercise on the ISS, loses mass about 1% per month. So imagine if you don't do any exercise, you lose bone mass. So that's not good neither. And in addition, GCRs, or galactic cosmic rays, go through many different materials that we have, and that definitely damages the actual cell, the DNA in your body. And we haven't figured out, what exactly can we do to prevent that, because it's not an easy thing to solve. So we have to figure that out. We need to be able to design and build either suits or structure that keep our astronauts safe and, prevent the damage from the space radiation. So that's two things right there. Exercise, because of the lack of gravity and the exposure to the GCRs, that is, creates havoc to your DNA. But in addition to just keeping the astronaut safe, I would say is, the as we were talking earlier, is the actual, propulsion. Uh, propulsion we have today is still, it's like, think about if you bought a brand new car today, let's say, whatever car you want, BMW, and compare that to a BMW from the 1950s, is basically the same technology, right? Gas into a combustion engine, produces, forward. That's no different from the rockets that we're launching today. Yeah. Is it a newer turbo pump? Yeah. Is it a different type of distribution system so it's safer? Yeah. But it's still the same basic physics. So until we develop something better, faster, we probably not going to be going that far out.
Okay, here's a couple of questions from Puerto Rico. The first one is from Chiara Rivera, and she's asking, are there any opportunities for industrial engineers in NASA? And the next question is from Walbert Joel from Toa Alta in Puerto Rico. Is NASA looking for new pilots, or are the pilots applications saturated? And we have chance for 2 more questions, and that's it.
All right, so for the industrial engineering question, my bachelor's is in industrial engineering from the University of Florida. And then I got a master's and PhD in industrial engineering from the University of Central Florida. So yeah, I think industrial engineers are allowed. That's that one. On the pilots, so the last astronaut class that was, I think he's talking about astronauts, not pilots. So NASA ceased to have, at least the big NASA center ceased to have planes to go back and forth. The only center that has planes in which they do research on is the Ames Research Center. They do have, and I think White Sands, they do have planes and associated pilots. So if the gentleman is actually looking for a pilot job, I would ask him to look into the Ames Research Center, White Sands Center, forgot the, White Sands. They're the two that do research on planes mostly. Because Langley does research, but it's more like wind tunnel, where Ames actually, they take the planes out and do experiments on.
Okay, so another very interesting question, and probably this is the last one. Probably we have one more after this one. This is Kathleen Velasquez from Carolina, Puerto Rico, and she's asking if, and this is very interesting, are homeschoolers accepted in internships at NASA? So when they're not going through a formal school, but they are being homeschooler, how they can get, yeah.
Homeschool. So if you're not going to a like a university, but instead of university, you're being homeschooled?
No, I think that it's middle school.
Oh, middle school. So we don't hire middle school folks. It's mostly college that we do hire, and typically the kids are associated with a university. So yeah, so I'm not sure about that question.
Okay, and the final question, and this is in your ISS experience, and we will finish with this. This is from Alanis Mercado from Toa Alta, Puerto Rico, and the question is, will NASA continue to use the International Space Station after putting Gateway into the lunar orbit?
Ooh, that's a really good question. To be honest, I hope, but do I know? Not sure. It becomes a funding issue for sure. It becomes a political issue. For the ISS to continue, we need to make sure that we have international support. Today we have the Russians, we have the Canadians, we have the Europeans, and we have the Japanese, right? And us. And the European is kind of like, it's the European Space Agency. So it's just not just one country, it's a conglomeration of many. So they need to be able to continue to support the ISS. So that means that they have to go through their governments and get approval, just like we do. So I'm hoping that continues, because the ISS, in my opinion, could still go for a lot further. It's a marvelous of a design and a machinery that's been operating now close. So I hope so. Now with Gateway, it's going to be smaller, so it's not going to be as big as the ISS. It's going to be very smaller. It's the little portal that once we launch from here, will attach to that lunar orbiting post, such that then astronauts could then go down to the surface, do their operations, and then once they're done with the surface operations, go back to the Gateway, finish off, and then come back home. So funding wise, I'm hoping that the Gateway is not going to be as that of the ISS. So I'm hoping to have those two continue. Plus all the research that the ISS is doing is just unbelievable. Things that we're getting out of it is great.
Okay, this concludes this session. We thank you very much, Dr. Nunez, for spending about an hour of your time, busy schedule. We will provide you with some other questions that we were not able to pass it to you because of time. And again, thank you very much. And thank you, everybody, that more than 500 people that were in this session and from all over the world. Again, thanks so very much. And this concludes the session. Thank you, Jose.